Hello, seventh graders, and welcome to chapter 2. This chapter, we're going to be dealing with rational numbers, and hopefully you remember the definition for that, and if not, don't worry, we'll be going over that. And we're going to be dealing with operations, and hopefully something comes to mind when you hear that word operations, such as add, subtract, multiply, and divide. So let's go over the definition for a rational number. Basically, it's numbers that can be written as fractions. So 1/2 is a rational number, 2/10 is a rational number. Anything where your numerator, which is your A, and your denominator is any number that is a non-zero. Actually, A could be a 0 and that would still be considered irrational. But let's go ahead and let me change this. Okay. So notice here our denominator, it says b cannot equal 0. This means cannot. So we talked about in the last chapter about how you can never divide by 0. So just like you can't divide by 0, you would never have a denominator is 0. And this also means, this fraction bar also means dividing. So all integers, fractions, and mixed numbers are what we consider rational numbers. Let me just underline that. So we have to do something with these fractions. And one of the things that we do is we simplify them. And what that means is all of your common factors have been taken out of the numerator and your denominator. So let's write a couple of fractions in simplest form. So here I have this fraction 21 over 49, or you can say 21/49. And I'm looking to say, okay, 21, I could write that as 3 times 7 over 7 times 7. So I want to take out, notice this common factors. So the common factor that I have is this 7 over 7. So I'm going to divide out the 7 over 7, and I'm going to be left with 3/7. So there is nothing else I can factor out of this, so we would call this one fraction in simplest form. Let me highlight that for simplest form. And then here's another fraction, negative 25 over 40. Now, notice that this negative, we're just going to kind of ignore that for right now. We'll just put it off to the side. So negative, and then 25 can be written as negative 5 times 5. And then I'm going to put that over some of the factors for 40. So if I did 5 times 8, I know that I have this common factor of 5 over 5. So we'll actually just cross this out right here. And I'm going to be left with a negative 5 over 8. So this negative sign would always stay there. You could also write it on the bottom. It doesn't really matter because you're kind of pulling it to the side and then adding it back on at the end. And I think the more that you practice with the negative fractions, the more familiar it will be. So take a look at these next ones. And we have 3 fractions. I want to see if you can find any patterns. So what they mean is I'm representing the same number and it has the same value. So just like we all have the same value, we just look a little different. So 2/5 is equivalent to 4/10, which is equivalent to 6/15. So here we go. I'm just going to put this little equal sign. And I wonder what we multiplied 2 to get to 4 and 5 to get to 10. So what did I multiply? Yeah, you can see that it's a 2. So this 2 over 2 to get to 10. And then going back to my original fraction, 2/5, what did I multiply to get 6? Yep, 2 times 3. And then whatever I do to the numerator, I have to do the same to the denominator. So then 5 times 3 gives me 15. So we can say that all of those are equivalent. I'm going to go ahead and erase those. So these all equal. They all have the same value, but they just look a little different. So one of the ways that we can identify equivalent fractions is when we write them in their simplest form. So if I have two fractions and their simplest form are the same, then I know that they're equivalent. So let's take a look at this fraction. Now, one of the things that I look for to see if there's I always start with a 2, 3, 5, and a 7. And you can always write these down and see. These are the first factors that I'm going to try to look at to see if I can factor out from the numerator and my denominator. So I don't have a 2 in both, so I know that that won't work. And I don't have a 3 in both, so that won't work. And there's not a 5, and there's not a 7. So that's kind of your indicator that those are already in simplest form. But let's take a look at this next one. And going back to my 2, 3, 5, and 7. So I want to look to see, can I pull out a 2? Well, because they're even, I know that I can divide out by a 2. So I'm going to divide by a 2. Oops. Divide by a 2. And that's going to leave me with 9. And then 48 divided by 2 is 24. Close that, make it look a little bit more like a 9. Okay, so I've already factored out a 2. And there's not another 2 I can factor out because 9 can't be divisible by 2. So then I want to look at my 3 and say, can I divide the top by 3? Yep. Can I divide the bottom by 3? Yep. So I'm going to go ahead and divide out by 3. And that's going to leave me 9 divided by 3 is 3. And 24 divided by 3 is 8. Oh, where have I seen that fraction before? Yep, right up here. So I would say that these two fractions are equivalent. Okay, so Ms. Peterson is going to show you another way to identify equivalent fractions.
So another way we can look at this is using cross products. Now cross products is similar to when I make my Band-Aids. Not is similar, it is the same. Okay, so I want to multiply 3 times 21 and see, we're not sure, so it's a question mark, if it equals 7 times 10. Okay, well, if I multiply 3 times 21, I should end up with 63. And 7 times 10 is 70. And are those equal? No, they're not equal. Because they're not equal, they are not equivalent fractions.
And that's a pretty quick, easy way versus going to make it simplest form, because sometimes that could be hard to factor out.
And I just want to make sure that, is that the section?
Yes.
Okay, next. No. I'm just looking at equivalent fractions that kind of confuse me. So multiplying or dividing the numerator and the denominator by the same non-zero number. Okay, so when we're doing this, we're talking about, some people will call it the magic one. Some people will call it the copycat, because when we're looking at 4/10, we're looking at that fraction and we're saying that I'm going to divide it by, I guess I don't actually want those, I'm sorry. I'm going to divide it by the same fraction, 2 over 2. Okay, when I do that, right, this is called the magic one because 2 over 2 equals 1. Or it's a copycat because the numerator and the denominator are the same. So 4 divided by 2 is 2. And 10 divided by 2 is 5. So our equivalent fraction here is 2/5. Okay, if I could keep dividing, I could find more equivalent fractions. But the next one is going to be where I look at 4/10, and now I'm going to multiply. And again, we like to choose the easiest number. I mean, it's certainly possible to multiply by 20 or 700 or whatever number you want to multiply by, but we like to stay small just to make it the easiest for us. So again, 4 times 2 is 8. 10 times 2 is 20. And here is another equivalent fraction. So 4 tenths equals 2 fifths equals 8 twentieths. Okay, so looking at simplifying and evaluating an expression. This one's going to be kind of complicated just because it takes steps. Okay, so the first thing it tells us to do is factor the numerator and the denominator. So when I factor, I actually want to change to the pen just so it's a little bit thinner here. When I factor, I'm going to say, okay, 2 times 2 equals 4, so I'm just breaking it down to the smallest thing possible. And what does x squared mean? I'm pretty sure, doesn't that mean x times x? Isn't that the same? Okay, and then we're going to multiply it by y. So that's what the top looks like when it's all factored down. And then on the bottom, well, 6 equals 2 times 3, right? Put it in its factors, and then there's times x. So right now, just saving ourselves time, I can automatically cancel out the 2. I can cancel out the x, and I'm left with 2xy over 3. Now I just want to take the time to evaluate it. I'm going to substitute in the values. So x is -2, so I have 2 times -2, don't forget to hug it, times 3, okay, divided by 3. But again, I'm going to look here, 3 divided by 3, can I simplify that first? I can, to make it easier, and I can now just say 2 times -2 equals -4. Notice I also could have gone there and said I could have done 2 times -2 is -4 times 3 is -12, and then divided by 3. I could have done the multiplication and the division and still gone to the same place as -4. And that's it. We will see you in class. Bye.